Hello dear students, welcome once more back to the GCE panel online. In today's presentation, we are looking at June 2022 Pure Math Mechanics and Pure Math Statistics Paper 1. It will be very important for you to subscribe to this channel so that you'll be able to have access to the Paper 2 and Paper 3, without which you will not be able to watch. We are equally begging on you, our dear viewers, please share our videos, leave your likes, leave your comments. That's what's going to motivate us to make more videos for you. You can equally follow us on Facebook, on Twitter, on YouTube, and so on. Please don't forget to subscribe, leave your comments, and interact with the community. God bless you as you prepare for your exams, and we hope that by the end of this week, we should have not less than 1,000 subscriptions from you. Share our content on Facebook. Welcome back to part 3 of this particular edition of June 2022 Pure Math Mechanics, Pure Math Statistics Paper 1. We are continuing from questions 36 to 50. In the first set, we look at the first 20 questions, then we continue from 21 to 35, and now this 36 to 50 is strictly Pure Math Mechanics Paper 1. So let's begin with the first question. A particle has a position vector r at time t seconds, given by r equals that. The velocity and acceleration of the particle when t equals 0 are. So to get velocity from the position vector, we differentiate. So this is going to give us v to be equal to 2e to the 2ti plus 3e to the 3tj. Now note, with most of our vectors, we might sometimes leave out the signs itself. So when you take our questions, you understand online, because typing most of those things is not very easy. So you understand. So this is our v, but at t equals 0, we are going to have v to be equal to 2, because e to the power 0 is 1. So 2i plus 3j, all of that meters per second. Now for acceleration is the derivative of velocity. So when we differentiate velocity again here, we're going to have 4e to the 2ti plus 9e to the 3tj. And at t equals 0, we will have 4i plus 9j meters per squared second. So the key here is A. Now, dear students, we have actually some videos on Mechanics 2 online, and as we mentioned earlier on, we have our Pure Math series, our Statistics series, and our Mechanics series. All these different seasons or series, because it's a video series or seasons with chapters, is just out there to help you to make sure that you prepare well for the exams. Please get to our content, subscribe to our channel, click the notifications bell so you're notified whenever we upload a video. Share our content to motivate us to make more. Like our content and leave your comments. Most of these things we are doing like this is actually to help you out there. The more we find out that you are sharing the contents, you are subscribed and you are using them, the more we produce. But if you find out that you are not interested in all of that, then we ourselves, you are going to be slack, and that might not be good for you. So question 37, a particle is projected from a point A on a horizontal plane with speed 10 meters per second at an angle of 30 degrees to the plane. The horizontal range covered by the particle is. So this type of question, you can just make a sketch. So this is the particle that is projected at this point here. So it's projected at this point here. Let us call it O. And from this point, this is the velocity that we have, which is 10. This is 10, right? So this is 10. And this is the angle theta, because they said from the horizontal. So since this is the angle theta, our x component of the velocity is given by 10 cos 30, and this y component is given by 10 sin 30 minus gt. Why minus gt? Because it is moving against gravity. Okay, we are moving away from gravity, then g is negative. If it was falling, g would have been positive. So from this point, we now have to find the value of t, but you know from here that at maximum height, that's maximum height at this point, we are going to have the time to reach the maximum height. This maximum height, v is equal to 0, so all of this will be equal to 0. So we equate that. When we solve that, we are going to have our t to be equal to 0.5 seconds. Now the time taken, that's the time of flight. Time of flight, the total time from this point here to the end at this point is given by 2 times the time to reach maximum height. Okay, so it's given by 2t. So our time of flight is equal to 2 times the time to reach maximum height. So that's going to give us 2 times 0.5, which is 1 second. From here now, we know that the time is 1 second. We can now have the range. The horizontal range is given by the time of flight times the horizontal component of the velocity. So our range should just be equal to 10 cos 30 times 1. Cos 30 is root 3 on 2. So we have 5 root 3 because we're going to have 10 root 3 on 2, which is equal to 5 root 3. So this is the range of the particle, okay? 5 root 3 meters. Our key here is C. Question 38. When the length of a spring is 60% of its natural length, the thrust on the spring is 10 newtons. What is the modulus of elasticity of the spring? So when the length of the spring is 60% of its natural length, okay, then so our force on extension here should be equal to 10 all over 1 minus 0.6, right? Because this one now, the thrust, when they talk about the thrust, what are they talking about? It means they have compressed it, right? The original length was 100%, but they have compressed it now to 60%. So what is the compression? The compression is 40% or 0.4. So the elasticity or modulus of elasticity of the spring is given by force over extension or compression. In this case, we have compression. Our compression is 100% minus 60%, which is 40%. So this gives us force over extension, which is equal to 10 over 0.4, which is 25 newtons. So this is the thrust. This is the modulus of elasticity due to the thrust, which leads to a compression. Please make sure that you subscribe to this channel. 2, click on the notifications. 3, like our video. 4, comment. And 5, share. When you do these 5 things on most of our videos, it's going to help us. Don't just share to people that are not interested in the content. Share to communities where we have students, be it WhatsApp group, Facebook groups, and all of that. It's going to motivate us to make more content. We are equally coming up with seminars on how to produce videos contents like this online. We equally have seminars to teach not just instructors but students as well as business people how they can work with Microsoft Word, Excel, Google Sheets, and all of that. So make sure that you join. Most of these things like this, they are free, though you may have just a small token of 1,000 or 2 to pay for registration. It's your knowledge you're going to gain will be something that you'll not be able to pay for. So guys, join us. Go to our website and have your inquiries about all of this, even how to make small websites and do WhatsApp marketing and all of these things. We equally have coming up with seminars on that, which is going to really help teachers as well as students. If you are interested in buying this our contents online or purchase equations, just go to our website. If you have any questions, you can use the WhatsApp button there to talk to us directly. Question 39. A centripetal force of 22 newtons causes a particle of mass 4 kg to move in a horizontal circle of radius 2 meters. The angular speed of the particle is. So first of all here, they have given us the centripetal force. And centripetal force is equal to mRw squared. That is mass times radius times angular velocity squared. Where Rw squared is angular acceleration. So mass times angular acceleration is equal to 72. Okay. So from here, we need the angular speed, right? The angular speed will be equal to 72 over 4 times 2. Because they said the radius is 2 meters and the mass is 4 kg. The square root of that is going to give us 3 meters per second. So our W is equal to 3. Question 40. 2 particles of masses 2 kg and 3 kg are placed at the points 31 and 86 respectively. The position of their center of mass at the point is. So for center of mass, first of all, we want us to get the center of mass from the point. All right, so to get the center of mass, we would like to use this point 31, right? Okay. So from 31, you can use from 31 or from 86. So from 31, center of mass will be equal to this coordinate, the x coordinate here first, plus 3 on 5 times the difference in the x. 8 minus 3, 3 on 5 times that. That's giving us 6. Then the y coordinate will be equal to the y coordinate here first of all, which is 1, plus 3 on 5 into 6 minus 1. That's the change in y. So this is going to give us 4. So our key here is A. Okay. Question 41. Figure 1 shows a uniform sheet of metal in the form of letter L with dimensions in meters. The distance of the center of mass from the edge AB is. So with this question, we have decided to actually add this other point so that we see how we can simplify and work with it. Here we can divide this shape into 2. We have this one like this, this oblong and this rectangle. So let's divide it and see. So we have this point. We have added the point C, the point D, the point E, the point F, and this other point here G. Okay. Now we come out with our table. This is our table here with the portion ABCG. ABCG. That's this oblong up to this point. Okay, this oblong up to this point. So divide the shape like this. ABCG. So we have that one. Then the weight. The weight of this one is going to be the area. The area is equal to the equivalent to the weight here. Okay, so 6 times 2 is 12. Now for this other one, DEFG. The area is also this space that I've reduced 4 here already, as you can see up here. This is 4, so we are left with they've reduced 2 here, so we are left with 4. So 4 times 2 is 8. The area of this portion is 8. Then, but the total surface area is 12 plus 8, which is 20. Now, the distance of the center of gravity of just this rectangle from this line AB is a half of this length now. Half of 2 is 1. So the center of gravity is around here, which is 1 distance away from this line. 1 unit. This is it, 1. Now, the center of gravity of this other shape, this second shape, DEFG now, from the line AB. Normally, the center of gravity of this one is midway. This length like this is 4, so it should be around here, which is 2, plus this other length of 2 here. So it's 2 plus 2, which is 4. The center of gravity is around here, which is at the point 4. That's why you have 4 here. Now, for the total shape, the center of gravity is at the point X. Okay? So from here now, the center of gravity from the HAB will be equal to 12 times 1 plus 8 times 4, which will be equal to, that's the sum of the individual ones, should be equal to the that of the total, 20 times X bar. From here, 44 is equal to 20 X bar, and our X bar is equal to 2.2. Normally, you could even guess with this one that is after this point of 2 point something, but you will not know whether it's 2.2 or 2.5. So this is the center of mass of this object. Don't forget to subscribe to our channel, leave your comments, like, share on WhatsApp. Please, and please. We are begging you until catarrh and tears are coming out of our eyes and nose. We are begging you, please subscribe, please share our content on Facebook and on WhatsApp. We are actually begging you on our knees so that you can help students who are out there suffering. Students who are out there and they don't have teachers for months. Teachers are not coming to teach them. Students who are out there, they want to do it, but they are trying to catch up with life. They have a job on one hand, school on the other hand. They need this second part of education to help them, to complement what the teachers are going through. Even teachers themselves are suffering. They need things like this to help them, the academics, so that students can equally follow from somewhere and boast performance. This is not just for the panel. It is for you students, for you teachers. Equally help us, because we answer a lot of questions every day. But from these videos now, if you share them, we will have answer less questions and have more time to produce more videos, which is actually going to help. Thank you in advance, because we know you're going to do it. If you can have up to 300 or 400 subscribers this week, then it is thanks to you. Please share to as many groups as possible. If you really love this panel and want the continuation of this panel, this is your own contribution we are asking you for. We are asking you to do this, not just for us, but for you. Question 42. A uniform ladder AB of length 2A rests on a rest limiting equilibrium with its top end against a rough vertical wall, as you can see, rough vertical wall, and its lower end on horizontal floor. This is it, rough horizontal floor. The forces acting on the ladder are shown. So all the forces are acting. This is the ladder that is lying on the wall. Okay, so the tendency is that it should slide downward. So friction is acting upward of 6 newtons. Yeah, tendency is that it should slide to this direction. So friction is acting in the opposite direction of 9 newtons. Then this normal reaction here is 36 newtons. Normal reaction here is 9. If you look at the sum of upwards and downward forces, upward force here is 36. Downward forces, upward forces, you have 36, this one plus this 6, which is 42. Downward force is 42, so they are balanced. As I said, limiting equilibrium. Then forces to the right, 9 newtons, and to the left, 9 newtons, so it's balanced. So for us to find the angle theta here, the angle theta which AB makes with the floor, we just need to take moments. And where do we take the moments? Should we take the moments here, where we are looking for the theta at A or at B? So normally, we can take the moment at A or at B, but now it might be easier to take it at A, okay, where the theta is found. So forces are already in equilibrium. What you just need now is to take the moment at a given point. Let's take moments at A. So taking moments at A or B, whatever. So this is what we are going to have. We first of all look at this angle and we come out to this side. So our OB here will be equal to 2A sine theta, because the length of this ladder is 2A. And our OA is going to give us 2A cos theta. So we have our OA and our OB. Now, with these moments, we now have, all right, so at B, we have this 9 times the perpendicular distance. Perpendicular distance is OB, which is 2A sine theta, right? Now, this force that is acting at this point, then another force is acting. Another force is acting. All right, I think we take moments at A rather because we just have just these two, and that should be equal to the weight. So we have at this point A, let me adjust here. I've taken moments at A, not at B. So taking moments at A. So we have this 9 newtons times its perpendicular distance. This perpendicular distance is 2A sine theta plus this 6 newtons. Perpendicular distance from here is 2A cos theta. That should be equal to, because this one will turn it clockwise, right? This is also turning clockwise, but the weight of 14 newtons turn now anti-clockwise. Should be equal to anti-clockwise moment. 42 times. This 42 newtons act at the center of gravity, which is at the middle of this ladder, because they said it's uniform. So this middle will pass around the middle of this line AB. So it's a half of OA, sorry. Half of OA is just A cos theta. So that should be 42 into A cos theta. Now opening out the brackets, we have 18A sine theta plus 12A cos theta equals 42 cos A cos theta. Bring like terms together, we'll have 18A sine theta equals 30A cos theta. Dividing both sides by cos theta, we are going to have tan theta is equal to 30A on 18A, which is equal to 5 on 3. All right, so our key here is B, 5 on 3. Guys, please don't forget to subscribe and to leave your comments, your notifications, whatever. Subscribe and share our content. Thank you so much in advance. Now, question 43. A girl on a ship whose velocity is 4I minus 7J meters per second is watching a boat whose velocity is this. The speed of the boat as it appears to the girl on the ship is, so the girl is the one that is on the ship and wants to get the relative motion of another object. So the velocity of B with respect to G will be equal to 4I minus 7J minus 8I minus 2J, and this gives us 12I minus 5J. Okay, so that's the relative velocity. 44. A particle accelerating from rest has its speed v meters per second at time t seconds given by that. So the acceleration of the particle when v is 10 is, you're supposed to be answering this question with this paper in your hand. If you need this paper, there's a link below. Click on this link below and you will have access, get to this video, to our website where you can download the paper directly on one click. So from there you can get the paper on one click, with just one click. So here we need to know the acceleration when the velocity is 10. If the velocity is 10, we need to know the time when the velocity is 10 first of all. So you can now use that time now to calculate the acceleration. So from here, we have 6t minus a half t squared to be equal to 10. We bring like terms together and we'll end up with this quadratic equation. This quadratic equation, we now simplify. When we simplify and solve for t, we are going to have t minus 2 into t minus 10 equals 0, and from here t equals 2 or t equals 10. Now, how do we get acceleration from velocity? We differentiate. So differentiating this velocity, we are going to have 6 minus a half into 2t. So that just gives us 6 minus t. And when t is equal to 2, 6 minus 2 is 4. Okay, and when t is equal to 10, 6 minus 10 is also negative 4. But anyway, they have just given me the positive answer here, so we are going to just take our positive 4 and stay put. Don't forget to subscribe to watch paper 2 and paper 3 of this series. Don't forget to share. We are not only begging, we are kneeling. Share, subscribe, click on notifications, leave your comments, join our online classes, buy our materials, join us for many things. Because we have a lot of materials, but it's like students are not exploiting them, as well as even teachers. 45. A smooth sphere A of mass 4 kg traveling at 5 meters per second collides directly with a smooth sphere B of mass 3 kg traveling at 4 meters per second in the opposite direction. Let's first draw. So that's A of mass 4 kg traveling at 5 meters per second and collides directly with B of mass 3 kg traveled in the opposite direction with 4 meters per second. So that is it for before. Given that the speed after impact is 0.5 meters per second for A, what is the kinetic energy of B after impact? So before, we have 4 times 5, that's momentum before, is equal to, for momentum after, we are going to see. Now this one has a higher momentum. So the tendency is that these particles will actually, after collision, they should move to the right. Okay, so this is going to give us A is moving to the right, B is moving to the right. But now the speed of A after impact is 0.5, while the speed of B we don't know. We need the speed of B to calculate the kinetic energy. From here, the velocity of B is equal to 2. So the kinetic energy of B will be equal to half mass times velocity squared. So half times 3 times 2 times 2, which is 6 joules. So the kinetic energy of B after the impact is 6 joules. Question 47. The work done by a force F equals that which moves its point of application from point A, position vector that, to another point B is. So this question, the answer was actually some sort of not there. So work is equal to the product of force and displacement. The displacement is the difference, the relative distance. So RB minus RA. Okay. So this is going to give us 1 dot dot dot. Okay. So when we do this dot product, we are going to have 1 minus 2 minus 4 times all of that. Okay. All right. Question 47. The engine of a car of mass 1,200 kg works at a constant rate of 54 kilowatts up a road, inclined at an angle of sine inverse of 1/5 to the horizontal. Given that the known gravitational resistance to the motion of the car is 300 newtons, and taking G as 10, what's the maximum speed of the car? The maximum speed of the car occurs when the acceleration is 0. So at Vmax, acceleration is equal to 0. So let us sketch what we have here first of all. So this is the inclined plane. That's the object resting there of 1,200 kg times G. So its weight, because I said G is 10. So this 12,000 newtons. Then the components down the plane will be equal to 12,000 times sine theta, which is 1/5 times. Okay, so that's what we have. Mg sine theta. All right, this mg sine theta here, this is 1,200 times 1/5 times 10. Then for friction, we have 300. That's as they were saying. Then the next thing that we need now is the pulling force. Now the pulling force is given by power divided by velocity, okay, which has been given as they have given us power as 54 kilowatts. So from there, how do we have force from power? Force equal to power divided by velocity. So now working parallel to the plane, we have 300 plus 2,400 is equal to 54,000 divided by V. And from here, our V will be equal to 54,000 divided by 2,700, which is equal to 20 meters per second. That's the maximum speed of the car, because acceleration is equal to 0. 48. A block of mass 4 kg slides down a rough plane inclined at 30 degrees horizontal at a constant speed. The block covers a distance of 8 meters. Taking G as 10, the work done against friction is. So it slides down a rough plane, right, inclined at 30 degrees horizontal at constant speed. Constant speed means acceleration is equal to 0. So it's sliding down to mg, that's normal reaction to the plane. Mg sine theta, that's 40 sine 30. Up the plane, you have frictional force. So from here, 40 sine 30 is equal to our frictional force, because acceleration is 0. So frictional force should be equal to 20 newtons. And if frictional force is equal to 20 newtons, then the work done against friction will be equal to force times distance, because it actually moves a distance of 0.5 meters. Okay, so this is going to give us 20 times 0.8, which is equal to 16 joules. So this is the work done against friction for this question. Guys, please don't just be watching these videos and you are not subscribing. You need to subscribe so that you can be able to see some, because there are some videos you cannot see because you are not subscribed. Most of the time students complain we cannot see this video, you cannot see it because you're not subscribed. We have made the videos in such a way that for you to watch some, you need to subscribe where you can actually see them. If you're not subscribed, you cannot see. So please, please, and please, we are begging with catarrh in our nose, cough in our mouth, and all the other things, even dust on our bodies. We are begging, we are kneeling, we are crying. Please subscribe to this channel, share the videos. This is the upcoming Valentine's. You can even send this as a Valentine's gift to a friend to watch. Can change a student's life. Must not be gifts. Share these videos. Go to our blog, download questions there. When you share these videos, how does it help us? It helps us because it reduces the number of questions that we answer every day. Sometimes when send questions you cannot answer because they are coming in numbers, so many, and we don't have time for all of that. So please, this is your own duty to the panel. If you want to see this panel survive, you want to see this panel continue, please share our content, subscribe, click on notifications, and share on Facebook, share on WhatsApp, and share on in all study groups you find yourself in. Thank you in advance. Question 49. From a speed of 20 meters per second, a car decelerates uniformly to rest, covering a distance of 80 meters. The deceleration of the car is, so initial velocity is 20, it moves to rest, so v is 0, and the distance covered is 80. So acceleration from the laws of motion will be v squared equals u squared plus 2as, and from here we can find the value of our a. So our a will be equal to, since it's decelerating, negative 400 on 160, which is negative 5 on 2. Why is it negative 5 on 2? Because this car is decelerating. Sometimes you can say if you find acceleration and decide what and explain whether it's acceleration or decelerating. Here is decelerating because the acceleration is negative. Okay. So last but not the least question before we move to paper 2. So this question reads, two dice are thrown together. The probability of having at least a 6 is. So now when you throw two dice together, this is what happens. These are the possibilities. With the first one, you have 1, 2, 3, 4, 5, 6. This is sample space. So now 1, 2, 3, 4, 5, 6. So along this line, you have only 1, 6, this 6. Along this line, you always have a 6. Here, always have a 6. So what's the possible number of times you have a 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Which is equal to 11 on, how many possibilities are there? Number of possibilities is 6 times 3, which is 36. So 11 on 36. Okay? So you can equally use the laws of probability. Okay, because the intersection that you have 2, 6. This is it now, is 1 on 36. So the probability will be 6 on 36 plus 6 on 36 minus 1 on 36. You can use those laws. Thank you so much for watching. We are expecting you to see you in paper 2, where we are hoping that after subscribing, you will join us there. We are hoping that you equally leave your comments. You will share our videos on all platforms. We need to have at least 500 subscribers this week, and we are counting on you. Please, if you can even share to 500 people or 500 group or all your WhatsApp links and contacts, you're going to help us. You're going to help so many students out there. Going to put smiles on people's faces. Many students have helped students out there without even knowing, just by subscribing, just by sharing content, and just by leaving their comments. Thank you so much, and we are praying that the Almighty God bless you as you're preparing your exams. Inshallah, mashallah, God bless us, God watch us, God protect us. See you. You can equally watch our lectures and contents.
GCE panel.